This demo video shows the mine planning and scheduling solution built on the Carbon-14 modeling technology developed by the Cyest Corporation. Carbon-14 is a production, planning and scheduling solution for the mining industry that allows for the generation of a rules-based production schedule and the associated economics. This allows for the rapid generation of an accurate and valid mine production schedule with the associated costs, labor, and valuations so that alternative strategies and options can be evaluated and thereby determine the most optimal. In summary, this solution offers non-graphical interface, allowing for scheduling of different mine designs and options without the need for a detailed graphical mine design, and therefore quicker turnaround. Rules-based scheduling, allowing for rapid scheduling by excavation by configuring the standard scheduling logic applicable and replicating across the mine. Detailed geological information. Detailed geological information can be either inputted manually via an intuitive interface or loaded from existing geological systems. Resource leveling. Constraining of the detailed activity-based production schedule via resource allocation and priority rules. Resource consumptions and economics. Resource consumption calculation per an activity level of detail and the associated costs and labor required and resultant economic outputs such as revenue, profit, value, etc. What if and scenario capability. Testing different options relating to mines' designs, scheduling logic and efficiencies, resources configuration, and cost assumptions to test the impact on the objective function. And flexible implementation. It can be implemented as a standalone desktop application or enterprise solution. In the MRM mine planning value chain, our solution allows for the rapid generation of a production plan and the associated budget and economics. The solution consists of two modules. The first is the production scheduling module for generating the schedule, and the second, the resource costing module for generating the rules-based budget and economics. This demo video will focus on the production scheduling module only. Another video is available for the resource costing module and other specific functionality and what-if capability. This demo will show how a standard block with its associated subactivity excavations is set up and scheduled. In this example, you see all the blocks for a scattered breast mining layout with a footwall decline barrel cluster running down the center. The demo that follows shows how a user will configure the mine design and layout, the geological information, and the scheduling logic to generate a production schedule. Now, we'll go into the actual application. This screen allows the user to configure and build a mine layout and structure. The user creates all the entities and blocks to schedule. This design and layout can be imported directly from other graphical design packages. The user defines all the activities and subactivity excavations that will be performed as part of the mining method defined. In this example, these are subactivity excavations relevant to scattered breast mining. On this screen, the user defines the design groups with their applicable subactivities and their relevant dimensions. Other excavations such as winch chamber and ASG can also be defined. On this screen, the user defines the size of each mining block and all losses and assigns blocks to the relevant design group. The stratigraphy will now be set up per geozone. Any number of geozones and any abnormal zones can be configured as required. The user can design all relevant geozones required for the mining area and the stratigraphy relevant to each geozone with its geological information. In this example, we have created a reef layer with a hanging wall and footwall. If, for example, a pothole exists, this is taken into account by defining an abnormal zone within that layer. The user positions each subactivity excavation within the stratigraphy layers. For example, the stoping excavation is positioned on the reef layer, with the winch chamber and ASG positioned in the footwall. Each subactivity excavation is routed out of the mine to reef, waste, or other stockpile, and how much remains behind for sweeping and vamping is also detailed. In addition, the user can specify that only a portion is hoisted out of the mine and is left underground. For example, in mechanized mining, some of the haulage broken tons is used for road building and is not hoisted out of the mine. On this screen, the user defines the scheduling sequence and rules by creating links between activities and delays where applicable. The crosscut starts 90 meters from the start of haulage. After the crosscut is completed, the traveling way is then logically scheduled. Then the step over and raise is scheduled. The 3 ledging subactivities start at the same time. Also, the 6 stoping activities logic can start at the same time. Logically, after the stoping, the sweeping and vamping subactivity is scheduled. The stoping activities can happen only after equipping is completed. And after ledging, equipping can start. And after the raise is complete, the ledging can commence. The haulage is delayed while the crosscut is developed. Now, the complete mining cycle within a block is logically scheduled. This scheduling logic is then replicated across the whole mine for each design group. This allows rapid generation of a logical production schedule. The blocks are linked together using external links, which again is replicated across the whole mine. In this scattered breast example, the haulage in each block links to the next block. As you can now see when zooming out of the schedule, the whole mine has been scheduled and the level access dates are linked to the barrel sinking rate. The user can now generate various charts to see what the schedule looks like. What can be seen is that the schedule is unconstrained and follows the mining sequence set per subactivity and level. The user now has the ability to set what resources will be used per subactivity, which resources will be shared between subactivities, and how many of each resource is available per half level, level, or shaft. In this way, the schedule is now constrained by the actual resources available to undertaking the development and stoping activities. Looking at the new stoping meters squared, you can see that the schedule now generates a realistic output based on resourcing available. You can see that the production schedule has become smoothed. Now that the schedule has been generated, it allows for scenario and what-if analysis to be undertaken. For example, what if development rates are reduced? How does it impact the opening up of reserves and therefore the stoping rate? What if stoping team efficiencies change, and what is the impact on the schedule and overall production? What is the effect of changing the stoping widths to see the impact on hoisted tons, grade, and shaft NPV? What is the impact of back length and interlevel spacing on the mining ramp-up, unit cost, and NPV? Detailed videos of each of these scenarios are available. Flexible dynamic reporting is available and uses open architecture, allowing for reporting using any reporting engine such as Business Objects or Microsoft Reporting Services. In this demo, we will configure an Excel pivot table report to demonstrate how the production per subactivity excavation per level can be set up dynamically. Standard template reports are available, and the user can configure specific reports as required, which are then available at the press of a button. Thank you. This is the end of the high-level overview of the Carbon-14 mine planning and scheduling solution. Further videos are available to demonstrate specific functionality and how this solution can be used to generate business value through scenario and what-if functionality.